If you were to walk through a forest in central Chile, the peatlands of Sumatra, or the rolling hills of New Zealand today, you might notice something striking. The trees are tall, straight, and impossibly green. To the untrained eye, this looks like a thriving ecosystem, a testament to nature's resilience, or perhaps humanity's commitment to regreening the planet. But if you stop and look closer, the illusion begins to fracture. The undergrowth is sparse, sometimes entirely barren. The silence is heavy, devoid of the chaotic symphony of bird calls and insect hums that characterizes a living wild place. And the trees themselves are uniformed soldiers, standing in perfect, equidistant rows. This is not a forest, it is a farm. We are witnessing a planetary transformation that scientists have recently termed the sprinter shift. It is a phenomenon where the complex, slow-growing, and resilient backbone species of the world's forests are being systematically replaced by sprinters, fast-growing, short-lived, and resource-hungry trees. From the industrial plantations of eucalyptus in South America to the vast monocultures of acacia in Southeast Asia and pine in Europe, the world's arboreal makeup is shifting from a marathon to a sprint. This shift is not merely an aesthetic change or a shift in logging practices, it is a fundamental rewiring of the Earth's biosphere, driven by an insatiable economic appetite for timber, pulp, and bioenergy, and paradoxically accelerated by well-intentioned but flawed climate policies. This transition threatens to destabilize the global carbon cycle, decimate biodiversity, and displace communities. We are trading the ancient stability of the oak, the teak, and the mahogany for the fragile speed of the pine and the poplar. In doing so, we are building a house of cards out of the world's forests, one that may not withstand the coming storms of the Anthropocene. To understand why this matters, and why the world's forests are becoming dangerously fragile, we have to look at the biology of the trees themselves. We need to understand the fundamental trade-off that governs life in the canopy, known in ecology as the fast-slow life history spectrum. For millions of years, the world's most stable ecosystems were dominated by conservative species. These are the tortoises of the plant kingdom. Trees like the European oak, the Amazonian mahogany, and the Southeast Asian dipterocarps evolved to play the long game. They invest heavily in dense, durable wood and thick, nutrient-rich leaves. They grow slowly, often spending decades in the shaded understory, biding their time before reaching the canopy. Their high wood density makes them resistant to rot, pests, and physical damage. Physiologically, they are built for survival, capable of weathering droughts and storms that would snap lesser trees in half. In contrast, the sprinters, species like Pinus radiata, Eucalyptus globulus, and Acacia mangium, are the hares. They evolved to colonize disturbed lands quickly. Their strategy is acquisitive. They have low wood density, light and cheap leaves, and hydraulic systems designed to pump water at breakneck speeds to fuel rapid photosynthesis. A sprinter does not care about longevity. It cares about dominating a space before anyone else can. This biological difference might seem like just a quirk of evolution, but recent research published in Nature Plants has revealed a terrifying vulnerability in this strategy. The study, which analyzed over 31,000 tree species globally, found that the very traits that make sprinters profitable, fast growth, and efficient water transport, make them deadly fragile. To truly grasp this peril, one must zoom in to the microscopic level of a tree's vascular system. Trees transport water from their roots to their leaves through a network of conduits called xylem. Think of the xylem as a bundle of straws. As water evaporates from the leaves during transpiration, it creates a negative pressure, a pulling force that drags water up from the roots against gravity. In a 30-meter-tall eucalyptus, the tension is immense. Sprinters have wide xylem vessels that allow for massive water flow, supporting their rapid growth. However, this is a high-risk gamble. When a drought hits and the soil dries out, the tension required to pull water up increases drastically. If the tension becomes too great, the water column snaps. Air is sucked in through microscopic pores, creating a bubble known as an embolism. This process, known as hydraulic failure or cavitation, blocks the flow of water. Because sprinters have wide, interconnected vessels to maximize flow, this embolism can spread rapidly from one vessel to another, leading to systemic hydraulic failure. The tree doesn't just slow down, it dies suddenly and catastrophically. Conservative trees, the backbones, have narrower, safer vessels that can withstand immense tension. They use high wood density to reinforce their vessel walls. They can sustain photosynthesis, even in parched soils, where a sprinter would have long since perished. By replacing the world's drought-tolerant backbone species with hydraulic gamblers, we are creating forests that are one heat wave away from total collapse. The sprinter shift is not an accident of nature. It is an engineered outcome of the global economy. The drivers are threefold: the traditional demand for fiber, the rising bioeconomy, and the newly monetized value of carbon. The demand for packaging, tissue, and paper products has never been higher. To meet this demand, the forestry industry has standardized its operations around a handful of miracle species. Eucalyptus, originally from Australia, is now the most planted hardwood on Earth. It can be harvested for pulp in as little as 5 to 7 years in tropical climates. No native hardwood can compete with that turnover. This economic logic has turned vast landscapes into fiber farms. In countries like Brazil and Indonesia, the conversion is stark. Native forests, with their messy complexity and centuries-old trees, are viewed as inefficient assets. They are cleared to make way for the green oil of eucalyptus and acacia. A newer, perhaps more insidious driver is the bioeconomy. In an effort to wean off fossil fuels, nations, particularly in Europe, have turned to biomass energy. Power plants are converted to burn wood pellets, theoretically a carbon-neutral fuel. However, this demand creates a hunger for wood that natural forests cannot sustainably feed. The solution has been more plantations. Fast-growing pine and willow are planted specifically to be harvested, chipped, and burned. This creates a perverse incentive where forests are grown not to store carbon, but to be emitted into the atmosphere, all subsidized by green energy policies. But perhaps the most tragic driver of the sprinter shift is the very mechanism designed to save us, the carbon credit market. Corporations racing to reach net zero are pouring billions into reforestation projects. But carbon markets are often myopic. They pay for tons of CO2 sequestered, and they want those tons now. A slow-growing oak might sequester a massive amount of carbon over 200 years, but in the first 10 years, the timeframe relevant to a corporate quarterly report or a 2030 climate target, it sequesters very little. A sprinter like a poplar or pine, however, sucks up carbon furiously in its first decade. This time value of carbon bias creates a financial penalty for planting native, slow-growing trees. Carbon project developers, incentivized by the market, opt for monocultures of fast-growing exotics. They can sell the credits sooner and at a higher volume. The result is carbon junk. Forests that look good on a spreadsheet today but may burn down, die of drought, or be harvested in 15 years, releasing that carbon right back into the atmosphere. This abstract trend manifests in brutal, tangible ways across different continents. In the Biobío and Araucania regions of Chile, the sprinter shift is a story of violence and thirst. During the dictatorship of Augusto Pinochet, the regime passed Decree Law 701, a subsidy that paid up to 75% of the cost of planting pine and eucalyptus. The policy worked. Today, millions of hectares of central Chile are covered in dense, dark plantations of Pinus radiata and Eucalyptus globulus. The forestry industry boasts of its contribution to the economy, but the local reality is different. Indigenous Mapuche communities call these plantations green deserts. The trees are planted so densely that no light reaches the forest floor, killing the undergrowth where medicinal herbs and berries once grew. Worse, these thirsty sprinters act as biological pumps, sucking the groundwater dry. Native deciduous forests in Chile rest during the summer or have lower water rates, but the exotic plantations are evergreen and grow year-round, transpiring water continuously. The result is that streams that have flowed for centuries dry up when plantations arrive. Communities are forced to rely on water trucks delivered by the government, a humiliation that fuels radical resistance. In the summer of 2017 and again in 2023, these regions burned. The plantations, filled with resinous, flammable pine and dry leaf litter, acted as colossal fuel loads. The fires moved with terrifying speed, fueled by the very biology of the sprinters. For the Mapuche, the sprinter shift is not just an ecological issue. It is a continuation of colonization, where their ancestral diverse lands are replaced by a foreign, extractive monoculture that steals their water and invites fire. In Sumatra and Kalimantan, Indonesia, the sprinter shift has collided with one of the world's most critical carbon sinks, tropical peatlands. Peatlands are waterlogged ecosystems that store gigatons of carbon in the soil. To grow Acacia crassicarpa for pulp and paper, companies dig vast canals to drain the water. The peat dries out and begins to oxidize, releasing massive amounts of CO2 even without fire. But the fire always comes. The dried peat is like tinder. When the acacia plantations, themselves highly flammable, catch fire, the peat underneath ignites. These fires can burn underground for months, creating a toxic haze that chokes Southeast Asia. The irony is palpable. The acacia is planted to produce renewable paper and packaging, yet its cultivation on peatlands turns the land into a carbon bomb. In China, the Grain for Green program represents the largest reforestation effort in human history. Billions of trees have been planted to stop desertification. While green cover has increased, studies reveal that a significant portion of this forest is actually monoculture. In many areas, diverse farmlands or native scrublands were replaced by single-species stands. While green on a map, biodiversity in some regions plummeted. Native birds and bees, adapted to complex ecosystems, found no home in the silent rows of the new forests. Furthermore, in the arid Loess Plateau, the planting of thirsty, fast-growing trees has depleted soil moisture to dangerous levels, threatening the long-term survival of the very trees meant to save the land. The shift from diverse backbones to uniform sprinters has cascading effects that reshape the entire web of life. A natural forest is a hotel with a million rooms. The cracked bark of an old oak, the varying heights of the canopy, the dead wood on the floor. Each niche supports a different species. A sprinter monoculture is a hotel with only one type of room. It supports only the few generalist species that can adapt to it. A study in the Amazon found that replacing primary forest with plantations resulted in the loss of over 90% of bird, amphibian, and beetle species. The complex interactions of pollination, seed dispersal, and predation collapse. Biologists also worry about functional homogenization. As we spread a handful of commercially viable species across the globe, we are erasing the unique biological identity of regions. A pine plantation in South Africa looks, smells, and functions eerily similar to one in Scotland or Chile. We are McDonaldizing the world's forests, creating a generic, simplified biosphere that lacks the unique adaptations evolved over millions of years to handle local pests and climates. This leads to a stability crisis. Monocultures are structurally unsound. In a diverse forest, pests and diseases have a hard time finding their hosts. If a beetle kills one tree, the next tree is likely a different species that is immune. In a monoculture, the next tree is a genetic clone of the victim. An infestation spreads like wildfire. We are banking on these forests to save us from climate change, counting the carbon they sequester in our national inventories. But this math is dangerous. Carbon stored in a 500-year-old redwood is safe carbon, locked in rot-resistant wood, and a stable soil ecosystem. Carbon stored in a 15-year-old eucalyptus is volatile carbon, held in a system that is prone to fire, drought, and harvest. When we replace a natural forest with a plantation, or when we claim a plantation offsets fossil fuel emissions, we are trading permanent geological carbon for temporary, vulnerable biological carbon. If the plantation burns or dies of hydraulic failure, that carbon returns to the atmosphere. Fortunately, the sprinter shift is not going unchallenged. Across the globe, a coalition of scientists, indigenous peoples, and activists is fighting to reclaim the definition of a forest. In Chile, Mapuche land defenders are demanding the return of the Wallmapu, their ancestral territory. They are fighting for the return of the lawn, the medicinal plants, and the water that the plantations have stolen. Their vision of the land is one of a mosaic of crops, native forests, and homes, not a monolithic industrial grid. In the academic and forestry world, the Lübeck model in Germany serves as a beacon of resistance. In the city forest of Lübeck, foresters abandoned the industrial model 30 years ago. They stopped clear-cutting, stopped planting monocultures, and allowed the forest to regenerate naturally. They practice integrated process protection, harvesting single high-value trees and leaving dead wood for fungi and insects. The result? The forest became more diverse, more resilient to storms, and crucially, more profitable. By eliminating planting costs and producing higher quality wood, the Lübeck forest outperformed its industrial neighbors. It proved that you don't need sprinters to make a living from the forest, you need patience. We are at a crossroads. We can continue to treat the world's forests like warehouses, places to store standardized goods, for quick retrieval. If we do, we will inherit a world of green deserts, fragile ecosystems that crumble under the weight of a changing climate, leaving us with wood but no water, trees but no life. Or we can start treating forests like cathedrals, complex, enduring structures built for the ages. We can embrace the slow, messy, beautiful complexity of the backbone species. We can accept that true resilience takes time. We can turn to assisted natural regeneration, letting the squirrels and the wind plant our future forests, as farmers in the Sahel region of Africa have done to regenerate millions of hectares. We can reform carbon markets to pay a premium for biodiversity and permanence, rather than just speed. The sprinter shift is a temptation of the modern age, the desire for a quick fix, a fast return, a simple metric. But nature does not run on quarterly cycles, it runs on deep time. If we want our forests to survive the turbulent century ahead, we must stop sprinting. We must learn, once again, how to stand still and grow strong.